Welcome to the cloudonaut podcast. We are your hosts, Andreas and
Michael Wittig. And this podcast is all about AWS. And we share here our insights into AWS that we basically get by our day-to-day work, which is more or less 100% AWS related. And this is episode number 74, and we are recording this on March 16th in 2023. And in case you are watching this live on YouTube, feel free to ask your questions in the chat, and we will answer your questions at the end of the show. You can also watch this on LinkedIn, and if you have any questions there, you can add a comment there, and we will make sure to read them before we close the show. And also you can at any time send us your feedback or your questions on Mastodon, Twitter, or via email. So those are your options to get in touch with us and ask us your AWS questions so that we can answer them here in the show. Besides that, Andreas, what we usually do here is that we share what we learned in the past week when working with AWS. And I think you have a couple of things on your list, Andreas, so that's why I hand it over to you now.
Yeah, thank you, Michael. So actually I was working on something, and the idea is that we need to distribute data to S3 buckets worldwide. So the idea behind that is our customers should be able to download the data from the region they are running their workload in. So our idea was to use S3 buckets, so one in each region, and synchronize basically the data to all those buckets, and then our customers can download the data from within their region. Because the beauty of that is that you're not paying for the data transfer from an S3 bucket to the local region, to the same region. So that's basically the idea behind that. And we have done that before. And our first implementation was using S3 cross-region replication. So that's a built-in feature for S3. And basically, you can turn it on and say, I want to replicate changes in this bucket to this list of other buckets. And then whenever you, for example, create a new object in the bucket, S3 will automatically take care of replicating that change to all the other buckets in the other regions that you have configured. And we have been using that for a while, and it's working fine. But I had the issue that I need to rely on the read after write consistency of S3. So a few years ago, AWS introduced that, so that basically now all our GET requests are consistent after write requests. And the thing is, I need to rely on that for this scenario. So this was important to me. However, the problem with S3 replication is that there are no guarantees around the replication. So it replicates the data, but you don't know how long it takes. I think we don't even know in which order the changes get applied. So I don't think there is a guarantee that this is in order as well. So overall, basically, S3 replication is great, but it breaks this read after write consistency that I need in this scenario. That was, I was basically, just using S3 application, but then I stumbled upon this issue, and now the thing that I have to do, or that I'm doing, is now I'm basically doing the replication on my own, which means I'm copying the data from one point to all these S3 buckets, basically with a script. That's of course a little more error prone, or I need to monitor that closely. But the advantage is that I get then the read after write consistency, so I can be sure that when the files are stored and then available in the order that I create them. So that was my learning around S3 replication, and when you should be careful using that.
Yeah, and that's a good thing to keep in mind, that if you somehow rely on a order of files or something, then you have to deal with that problem if you use S3 replication. And I think another kind of reason for us to not use it actually is that it's actually quite expensive There's a kind of way to kind of make it a little bit quicker. Like I don't know how the feature is actually called, but there's like a way to kind of make it replicate within 15 minutes in 99.99% of the cases or something with an SLA. And we turned that on as well. And this makes it a little bit more expensive. So for us, our use case is really we replicate maybe 100 files or something. It's not like massive amounts of files, but for us, it's important that certain files are replicated after the other files are done and things like that. Yeah. So that's definitely a good catch, Andreas. And it is actually an issue that we actually have in production, and now it's kind of resolved. Yeah, that's great. So what I learned, or to be honest, I didn't learn it kind of for the first time. I just was remembered that this is a big problem, is a performance test on an EC2 instance. And we wrote about this like for years, Andreas. The problem with performance testing on AWS is that more or less everything is elastic or burstable. So the first thing that is burstable, and this is obvious, if you're using a T2, T3 or T4 instance type, then your CPU is burstable. And I mean, if you run a performance test with a burstable CPU, then your numbers are kind of they don't tell you much basically. So you have to be careful. And what I did this time, like from the beginning, because I was aware of that problem, I configured the T3 instance to run in or without the unlimited mode. And there's big differences between T2 and T3 instances. A T2 instance receives a certain amount of burst credits when it starts. This means when the machine starts, you can burst for a specific period of time. A T3 does not receive any burst credits when it starts. It starts accumulating burst credits when it's not kind of at full running at full capacity, at the baseline capacity. And so you kind of can gain credits. But there's another feature that's turned on by default that's called unlimited. And with unlimited, you basically can buy credits when you're out of credits. So for an additional charge, you get burst credits basically to kind of solve this problem if you are in a situation where you don't have credits left. So what I did in my test is that I disabled the unlimited mode so that I know that I have only the baseline capacity available from the start. So I can run my test now on baseline capacity, and then I can also turn on unlimited, and I can run it at full capacity basically. And running it at full capacity still is a problem because you're not guaranteed to get those credits, right? I mean, if you're running on a host that is busy with other T3s, then you are out of luck. So this is the first really big issue that you have to think about, the CPU elasticity if you're running a T3 instance. I mean, you can fix that problem by going to an M5 or something like anything else than a T instance family, and you don't have this issue anymore. So the next problem with M5s, for example, also with T instances, is that the network is burstable. So the smaller instance types, and when I say smaller, this applies to 2x large instances. They are still not big in these terms. They have burst capacity on the network as well as baseline capacity on the network. So when you just run your performance test for 30 minutes and the network is the bottleneck in your application, then your application looks much faster than it actually is at the long term. So keep this in mind. There is no really good way to observe that behavior. So you cannot really look at the credits here. There's no credit mechanism that you can see from the outside. So you basically have to ensure that you kind of, at the beginning of when a machine starts, you kind of burst all the network capacity out of the machine, basically. So download a really large file for 20 or 30 minutes. Then look at the CloudWatch graph that it kind of goes down. Then you know you are out of credits. And then you run your workload or your performance test. And it gets even more problematic if you're using EBS volumes, which is the default, because they also have burst capabilities. So if your workload is disk bound, and then you also have to make sure that you're looking at those metrics. And the good thing here is that they are available today or these days, so you can have or you get insights into that. So just making sure if you run a performance test, you have to keep all that things in mind. So my recommendation therefore is that you run your tests for a longer period, not just for a couple of minutes, like for hours, and double check your data, like the data that you get out of your test, with your understanding or your assumptions of how this AWS thing works. So you would expect that it is quicker at the beginning and then it slows down over time. And if that doesn't happen, then you maybe double check everything. And otherwise you get numbers that are just wrong in the end. So I hope that makes any sense, Andreas.
Yeah, that's a very good thing. So Michael, I remember one huge outage that was caused after a migration from on-premises to AWS. And that's basically going in the same direction, because here again, the thing was the team planned the lift and shift migration. They did performance tests as well, because it was a very business critical system. And everything looked fine. And then I think it was on a weekend, they migrated the workload to AWS. Everything looked fine. And on Monday, after a few hours, the whole system basically broke down. And the throughput was basically crashing down. Errors were thrown, stuff like that. No one could use the system anymore. And this was for a similar reason. Again, I think in this case it was at the end because of the EBS volume throughput was basically just going through the credits and then dropping to the baseline performance, which was far below what was needed. And so I think, it is really, really important if you do performance testing of any kind of system on AWS, you definitely have to run the load test for I would say at least 1 hour, better a few hours, to really make sure that you're not running in any of those burstable resource things. Yeah, that's definitely important, and you cannot relearn that enough. So I think that's a good thing. Thanks for sharing, Michael. I've learned about another feature of AWS. It's related to EC2 instances, and I have been looking for a way to authenticate EC2 instances from a third-party system point of view. So basically, I built an API, and I needed to authenticate calls from EC2 instances. And as this is not running in the same account or something, using IAM roles or something was not an option here. So I was looking for a different solution. And it turns out that there is a thing called EC2 identity document. And what is that? So basically, the EC2 identity document is something, it's basically the ID card of your EC2 instance. In the instance identity document, there are you find information like the AWS account ID of the instance, the instance ID, the instance type, the billing product. So if you start something from the marketplace, you get the information about the product that you use. Stuff like that, the region, IP address, and some other things. So basically, you get information about the EC2 instance in the instance document. And you can use that to identify a machine, because AWS also signs that document. So you get a signature that you can then verify, and AWS shares the keys for that in their documentation. And so this is a way to implement an authentication of EC2 instances. And I was using that for basically implementing the authentication layer for an API gateway serverless application. And I think that's kind of interesting. And I was reading through the internet a little bit, and I found that I think, if I understood it correctly, HashiCorp with Vault is using that mechanism as well to authenticate EC2 instances. And I think I've also seen that a few years ago when I was working with Vault. So this is, I think, interesting. Yeah, so whenever you need to identify EC2 instances, for example, make sure that they are running in your account or something, and making calls to your third-party systems on-prem or wherever, this might be an interesting way to identify those EC2 instances. Basically, use the document and then the signature, the signed thing by AWS. So that is what I was using. It's you find there are different ways, different signature options, and yeah, so this is, I think, an interesting thing to know about at least.
Yeah, and Andreas, I think I wrote a blog post about that a couple of, I think, years ago as well.
Oh.
This is very useful for machine-to-machine authentication, right?
Mm-hmm.
So if you plan anything in that kind of field, then definitely check out the identity document, because this is a verified identity document that you get, that you can really be sure that this is the instance that claims to be the instance, and that's really helpful if you have systems where you cannot use an IAM role to authenticate, like if you talk to maybe also clouds or maybe data centers and stuff like this, and you want to go one level like further, not just network access control, but also strong authentication. That's really cool. Feature that we get in the cloud. I mean, that's really handy.
Yeah, so I think sometimes. So the question is, can you basically use one of the data in the identity document? Is that enough to identify the instance? So AWS account ID or something, is that really enough? Of course, you don't have information about the IAM role or something, so you cannot really group instances in the account or something. So yeah, as far as this is enough, then I think that's a good way. Or if the instance ID is enough, that's also a possible thing you could use. Okay, so Michael, I have one more thing. So I stumbled upon a few months ago. I filled out the AWS survey that Peter Sankauskas was running. So I think he's an AWS hero for quite a long time and very active in the community. And he was doing a community survey to find out which AWS services are popular and stuff like that. So I found that quite interesting. So I filled out the survey, and yesterday Peter published the results of the survey, and I found that quite interesting. And maybe we can go over that together. We can also I'll paste the link into the chat and into the show notes so that you can follow along as well. Yeah, let's go maybe through that. So the interesting things, there's one category, infrastructure as code. And what I found really interesting is that, I think more than 300 people replied to the survey. I don't know. That's not too bad, I would say. What I found interesting is that 82% of them are using CloudFormation, which is the most popular infrastructure as code tool from the usage perspective. So which tools are you using? Then it's Terraform and Ansible CDK. So that's the order of which tools are in use. And what I also think it's interesting that the tool that most people want to try or want to learn about is obviously, Michael, which is it? CDK.
CloudFormation, I don't know.
Yeah, CDK, of course. So that's what AWS is really pushing hard. So okay. That's the thing, the hot new thing that everyone is interested in. But at the moment, less than half of the survey respondents have been using it. So that's probably growing over the next few years. I found this interesting. Also, the next category was about CI/CD. And here it's really cool. The most popular tool from a usage perspective, so which tool are you using at the moment, is Jenkins. And what it's more interesting is the tool that the people are most happy with is GitHub Actions. So 99% of the people who are using GitHub Actions are planning to continue to do so. So they're not planning to switch away to any other tool. So I think that fits into our observation. We are also migrating to GitHub Actions nowadays, and are very happy with that. So I found that interesting. Then another interesting thing is the question was, how do you basically deploy serverless applications? And the most popular option here is the serverless framework and AWS SAM, sort of serverless application. Is it serverless application model, I think, which translates to CloudFormation at the end. And then behind that is then CDK. So again, everyone is talking about CDK those days, but really the tools in use are the good old ones, the serverless framework and SAM. I found that kind of interesting. And one more thing that I didn't expect maybe, so is what are the event-driven architecture services that people are using? And the most popular one here is SNS and SQS. Kinesis and EventBridge are less common used than those two options. I found that interesting. So we are using Kinesis, and actually I don't. Yeah, SNS is probably because it's probably an older service and has been around for some time. EventBridge is not that popular yet. Yeah, so I found that interesting to see how things are changing there. Yeah, maybe one last topic, the container workloads. So which tools are people using to run containers? So 77% are saying they're using ECS. And compared to that, only 46% say they're using EKS. And so I think that is also interesting to see what are people using to deploy their container workloads.
That's interesting. I didn't expect that.
Yeah, me neither. Because EKS and Kubernetes is so you a lot of blog posts, a lot of content around that, but what people are, it seems like what people are using is ECS. Yeah, that's interesting. Cool. Yeah, I found that interesting. So I think what would be cool to repeat that survey next year and then compare the results and see which services are growing and how the things change over time.
Yeah.
Okay, Michael.
All right, Andreas.
So that's it. We will be back. Subscribe to our newsletter, podcast, or YouTube channel to make sure you're not missing the upcoming shows. We are looking for your feedback, so hello@cloudonaut.io or find us on LinkedIn or Mastodon.
Yes, and we also, sorry for that, we also want to thank our supporters and who make the show possible. And if you are a fan of the show, please consider supporting us as well. And there are a couple of options, and you can all find them on cloudonaut.io/support us. You will also find the links in the show notes. So thank you very much for watching this and listening to the podcast, and have a great day. And the last thing I have to say is bye.
Bye.